God versus Nature, the conflict between religion and science in history. Chapter 9, Newton, Rationality, and the Arbitrary. The greatest scientist of the scientific revolution was undoubtedly Isaac Newton. His spectacular discoveries in optics, mechanics, and astronomy created a foundation for virtually all of the science of the following centuries. We will see in the next chapter that the impact of Newton's discoveries extended far beyond science and led to a society-wide confidence in reason that would characterize an age. English poet Alexander Pope wrote Newton's epigraph, quote, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." Unquote. In his scientific work, Isaac Newton was fundamentally a practitioner of inductive logic, which starts with observations of reality and integrates them into wider and wider generalizations. The other type of inference, deductive logic, applies general truths such as all mammals bear live young to more specific instances, such as zebras, allowing one to conclude, for example, that since zebras are mammals, they must bear live young. As Newton explained, quote, "Natural philosophy consists in discovering the frame and operations of nature, reducing them, as far as may be, to general rules or laws, establishing these rules or laws by observations and experiments, and thence deducing, i.e. inferring, the causes and effects of things." Unquote. As we will see, Newton identified a crucial principle of inductive logic, a principle that, when applied consistently, fatally undercuts religious ideas. The discovery of the laws of motion. As Newton himself pointed out, he, quote, "stood on the shoulders of giants," unquote. Two of these giants were Galileo and Kepler, who made key discoveries in mechanics and astronomy. Galileo's observations and experiments had led him to his law of falling bodies with constant acceleration, and a simple concept of inertia. Kepler's study of the orbit of Mars had led to his three laws of planetary motion. 1. The shape of a planet's orbit is an ellipse with the sun located at one focus. 2. A planet sweeps out equal areas in equal times. 3. The squares of the periods of revolution of any two planets around the sun are proportional to the cubes of their mean distances from the sun. Starting with these laws, Newton developed a new concept of force and three laws of motion, which he lays out in the first section of his Mathematical Principles of Natural Philosophy, published in 1687. 1. Every body perseveres in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by forces impressed. 2. A change in motion is proportional to the motive force impressed and takes place along the straight line in which that force is impressed. 3. To any action there is always an opposite and equal reaction. In other words, the actions of two bodies upon each other are always equal and always opposite in direction. Newton's most brilliant insight was to see that a single force does all of the following: keeps planets in their orbits around the sun, keeps moons, such as our moon and Jupiter's moons, in their orbits, causes objects to fall, holds objects on the earth, causes the tides. Newton organized his Principia in a rigorously deductive fashion, with the three laws of motion presented like mathematical axioms, from which he seemingly deduces everything else, one after another. But this organization, following the convention of other scientific works of the time, is misleading. It is essentially the reverse of the order in which he reasoned. Newton's rejection of hypotheses. The second edition of Newton's Principia included a general scholium, a general note at the end, where he famously said, quote, "Hypotheses non fingo," unquote. I do not feign hypotheses. His immediate point here was that he was not proposing a deeper mechanism that caused and explained the law of gravity, as Descartes had attempted to do. Newton was aware that there was no evidence for a specific mechanism, and that the mechanism proposed by Descartes contradicted known facts. In his note, Newton pointed out that he had discovered an important law of nature, and that this should be enough. Newton's statement that "I do not feign hypotheses" was also making a broader point, which can be seen in his approach to the study of light and color. This is the subject of his other major publication, Optics, or A Treatise of the Reflections, Refractions, Inflections, and Colors of Light, first published in 1704. After the use of telescopes became widespread, their users discovered that telescopic observations revealed bits of colorings that made the image fuzzy. Today, these are referred to as chromatic aberrations. People also knew that rainbows could appear when light went through raindrops, and that colors result from light going through prisms. Somehow it was understood that when pure white light was refracted, i.e. bent, at an interface, such as between glass and air, it was modified in some way to generate colors. Newton studied the theories of light and colors from Descartes, Hooke, and Boyle, but he found these unconvincing and essentially based on imagination. Deciding to undertake his own research of the subject, he purchased a prism and began experimenting with it in a darkened room with sunlight coming in through a pinhole. Surprisingly, the light, when refracted through the prism and shone on the wall, did not make a circular shape. Instead, it made an elongated shape with straight sides and circular ends, similar to an ellipse. One end had a red fringe. The opposite end had a blue fringe. Newton started wondering if blue and red were somehow already in the white light, but were refracted at different angles. So he tried an experiment. He took a straight thread and colored half of it blue and the other half red. Then, when looking at the straight thread through a prism, he saw the two halves as discontinuous and not in a straight line. This was a powerful piece of evidence that he was on the right path. This led him to a series of further experiments with the prism and other objects, including the famous experiment with two prisms, in which he separated white light into colors and then reconstructed it. This clearly demonstrated light's heterogeneity. Newton concluded that white light consists of a mixture of all colors, which are separated, but not otherwise modified, by refraction. Newton's approach to studying the nature of light differed in a key way from the approaches of contemporaries such as Descartes and Hooke, who began with certain assumptions about the nature of light and deduced the consequences of these. Descartes speculated that light consists of rotating particles, with the speed of rotation determining the color. Robert Hooke speculated that white light consists of a symmetrical wave pulse, which results in colors when the wave becomes distorted. But these speculations had no real evidence in their favor, and these were the types of hypotheses that Newton rejected. In a letter to a friend, Newton explained his attitude towards these hypotheses. Quote, "If anyone offers conjectures about the truth of things from the mere possibility of hypotheses, I do not see by what stimulation anything certain can be determined in any science. since one or another set of hypotheses may always be devised which will appear to supply new difficulties. Hence, I judged that one should abstain from contemplating hypotheses as from improper argumentation." Unquote. This was Newton's rejection of what Rand would call the arbitrary. Newton identified an important epistemological principle. The arbitrary is not to be entertained as possible. Otherwise, all our knowledge is invalidated. Quote, "Whatever is not deduced, i.e. inferred, from the phenomena must be called a hypothesis, and hypotheses, whether metaphysical or physical, or based on occult qualities or mechanical, have no place in experimental philosophy. In this experimental philosophy, propositions are deduced, i.e. inferred, from the phenomena and are made general by induction." Unquote. An arbitrary idea is one for which there is no evidence. Like the dragon in Carl Sagan's garage, it is a notion put forth based solely on whim or faith. Rand held that an arbitrary idea cannot be valid even as a possibility. In order to say it is possible, one needs to have evidence, which can consist of either direct observations or reasoning based on observations. This rejection of the arbitrary may be expressed in a positive form. One should be focused on reality, and only on reality. The arbitrary as non-cognitive. An essential principle of rational thinking is what some logicians have called the law of rationality, and which philosopher Harry Binswanger sums up as follows, quote, "In reaching conclusions, consider all the evidence and only the evidence." Unquote. He elaborates, quote, "Because evidence is the only means of gaining inferential knowledge, the rational mind accepts all that which the evidence shows, only that which the evidence shows, and only to the extent that it shows it. Only evidence, not someone's assertions, not feelings, not authority, not faith, can provide the basis for proceeding cognitively." Unquote. Ideas not based on evidence must be classified as arbitrary, which is an epistemological status different from true or false. Consider a simple example. Suppose I am getting ready to leave my house, and I can't find my keys. They are not on the bedstand where I usually leave them. Suppose the thought then strikes me that a monkey has taken my keys. I watched a documentary about African primates last night. I have no evidence of any monkey ever being in or near my home. So this idea is arbitrary, and the only rational course for me is to dismiss it. Of course, it is not physically impossible for a monkey to take my keys. However, for me to claim it is possible that a monkey took my keys would be unwarranted and arbitrary. It is solely based on my imagination. Imagination is useful in many ways, such as in entertainment, but it is not cognition, awareness of reality, and it should never be confused with cognition. To say maybe or it is possible imposes an obligation on the person who says it, the obligation to provide some evidence in support of the claim. In today's culture, one often hears someone advance an arbitrary claim and then say, "Prove it isn't so." But there is no burden of proof on the person who dismisses the arbitrary. In fact, it is an error even to attempt to disprove an arbitrary claim. Sometimes one can relate an arbitrary idea to a cognitive context and then show that the idea contradicts existing knowledge. Suppose someone suggests, without any evidence, that there is a zebra grazing in my backyard. Given that this assertion is arbitrary, I should simply dismiss it. But suppose I go ahead and look, and I see that the yard is empty. Then I conclude that there is no zebra there. Then the claim becomes false instead of arbitrary. The advocate of the arbitrary can then go ahead and insulate his claim from my observation. He can say, quote, "The zebra in your backyard is invisible and undetectable. Prove that my claim is false." The only rational response to this is, "Your claim is arbitrary. Therefore, I refuse to consider it." This discussion has merely touched on some of the issues regarding the role of evidence in reasoning and the invalidity of the arbitrary. For a detailed discussion of these issues, see How We Know Epistemology on an Objectivist Foundation by Harry Binswanger. Unfortunately, in today's world, arbitrary ideas are routinely considered in a variety of fields, including philosophy and law. The most prevalent source of arbitrary ideas is emotion, so let us examine the nature of emotions. The nature of emotions and faith. The uncompromising advocate of reason is often met by the objection, "But what about emotion?" Emotions have often been taken to give us some special knowledge by a special means other than reason. But this is not what they are. An emotion is an automatic, psychosomatic response to a situation, a response that reflects one's understanding and evaluation. Emotions merely involve the application of our existing ideas and evaluations, right or wrong, to the situation. They occur so quickly and automatically that it is easy to escape this fact. But it is crucial never to forget that emotions are a product of ideas, which can be wrong. Every emotion we experience involves a chain of events containing 4 elements. 1. Perception. I see a curved shape on the ground. 2. Identification. That is a rattlesnake. 3. Evaluation. My life is threatened. 4. Reaction. I feel fear. This chain occurs virtually instantaneously, and we are typically aware of only the first and the last elements, perception and reaction. I see a snake and I feel fear. People often experience conflicts between their reason and their emotions, but these are more accurately described as conflicts between their accepted ideas. For example, a man with an irrational fear of flying may tell himself that he recognizes that flying is safe, but deep down he doesn't really believe this. Part of the process of overcoming this problem involves fully integrating his thoughts and conclusions. Emotions do not have independent access to reality. The only way to know if an emotion is appropriate is by examining it rationally. This is not an anti-emotion viewpoint. Emotions play crucial roles in our lives, for example, as sources of enjoyment, motivation, and self-awareness. But they do not directly tell us about external reality. As Rand put it, emotions are not tools of cognition. Faith amounts to an acceptance of an idea based on emotion rather than of evidence. It is believing because you want to believe. Quote, "I want to believe in Jesus and that he loves me, therefore he does." Unquote. Faith undercuts the mind's need for evidence. The acceptance of faith leads to the complete rejection of the law of rationality. This is why Rand claimed, quote, "The alleged shortcut to knowledge, which is faith, is only a short circuit destroying the mind." Unquote. The person who accepts faith implicitly accepts the primacy of consciousness. To say, "I want X to be true, therefore it is true," is to say, my consciousness can directly control existence. If the existence of God could be rationally proved, then it would not be arbitrary. Theologians such as Thomas Aquinas thought they had such rational proofs. But, as many have pointed out, these are all fatally flawed. For a good discussion of these alleged proofs, see the book Atheism, the Case Against God by George H. Smith. The main reason people believe in God is not any rational argument, but their feelings. God is a father figure who makes people feel reassured that someone loves them and will take care of them. And the popular argument, if there is no God who created the universe, clearly presupposes the primacy of consciousness. Newton's inconsistency. Unfortunately, Newton did not see the full implications of his refusal to feign hypotheses. When it came to his religious beliefs, he accepted most of the conventional views of the English Puritan culture in which he was raised. He did not ask for proofs or evidence when it came to religion. Newton trusted the Bible as a historical document that was accurate except for certain corruptions. He often took the Bible literally, especially prophetic texts from Daniel and Revelation. He believed in predestination, the bodily resurrection of Jesus, the future resurrection of the faithful, and the millennial kingdom ruled by Christ. He even calculated a possible starting date for the events of the apocalypse, the year AD 2060. His private manuscripts on theology are voluminous, totaling 4 million words. While it is unfortunate that Newton spent so much of his time and intellectual energy on such pointless pursuits, it is important to remember him for his inspiring achievements and the extent to which he did, with spectacular results, apply his logical reasoning to science.